Welcome to a bonus episode of Shop Talk Live. Today's episode is brought to you by MatterHackers.com. MatterHackers is a place that I've been shopping at for a while, and they reached out and they wanted to have a conversation with us and talk about how woodworkers can bring digital tools into their wood shop. And not necessarily the most obvious of ways sometimes. So on this episode, we're sitting down with Dave Gaylord from MatterHackers and talking about all things digital woodworking, from CNCs and laser cutters to my personal favorite, 3D printing in the wood shop. So check it out. It's a fun episode. I learned a ton. If you are all interested in digital woodworking, I think you're going to learn a bunch too. So Dave, you're the VP of technology. What does that mean?
Yeah, so VP of Products and Technology at MatterHackers means really I oversee our product portfolio. So MatterHackers has been around for about 12 years, 11 or 12 years. And we were founded with the ambition to say like, hey, 3D printers are pretty cool. We should participate in that somehow.
Yeah.
And with that, we started actually with some free software that doesn't keep the lights on. So then we started selling some of the consumable material. And for 3D printers, consumable materials are filament. We call it filament. So it's the plastic that comes on a big spool. Mm-hmm. So MatterHackers started selling, we spun up a little website and started selling materials first. We got really lucky a couple weeks along the way that our, main competitors were out of stock. That allowed us to, purchase more and do more. But yeah, our portfolio, which I oversee, has really just grown like crazy over the last decade. From materials, we grew into hardware, so 3D printers themselves. We've even spun out and taken really, at the time, they seemed like leaps and adventures that were into CNC machines or, laser cutters, other what we call digital fabrication or digital manufacturing products. And if you're using a computer to control some piece of hardware to make a physical product, that's something we're interested in wanting to help all of our customers out with. So,
I think right off the bat, let's break things down into two camps. We've got subtractive manufacturing and additive manufacturing. And so a subtractive manufacturing process would be CNC. You're taking wood away. What else is in subtractive?
You could consider laser cutters being subtractive because you don't start with a block of wood or a sheet of wood. You start with a sheet of, it could be wood, could be cardboard, could be acrylic. Like laser cutters are actually really broad in the things that they can handle. The laser cutters would be the next one. We also have a pretty cool product called a water jet machine. So a water jet machine's used in big industry, right? It's something you'd see in a big sheet metal shop that be, cutting things out. It cuts big sheets with water. But that water's got a bunch of sandpaper grit in it. So it really cuts it. The water's just the medium for which to fire sandpaper grit at a high velocity.
Yeah.
At a just super high pressure. That's another subtractive because you're starting with a sheet good. That's less used with wood, but used with some really elaborate materials. You can use glass. You can use, I've even seen abalone guitar inlays cut out of the water jet machine because it can do really fine details. And it's got a really, you can control the kerf, so you can get inlays really detailed in exotic materials.
Okay, so we're already off of our notes, but this is exactly what we expected.
Notes are behind us.
Yeah, I can't imagine too many of our fine woodworkers out there getting a water jet, but thinking about it from a perspective, all right, so subtractive, you've got CNCs, and generally that is a familiar format for woodworkers. You've got a router bit of a diameter, but with a water jet, there's no real diameter to that kerf, you're saying? There is. So the water comes out in a nozzle, and that nozzle is of a certain diameter. So your kerf, right, is that nozzle diameter. Okay. Wow. All right. We're already in the territory that I didn't know you did. I didn't know that there was water jet in the MatterHackers lineup. This is great. Preparing for this podcast though, I've been shopping at MatterHackers, and that's actually how this started was
satisfied customer over there. Yeah.
Yeah. And literally just, I was showing you before, but for the listener, I'm holding up a MatterHacker box that came just 2 days ago with Filament.
Unsolicited.
Paid for in my own money. Yep.
Customer order coming through. Yeah. We try. You place your order. We try to satisfy you as quick as possible.
It was very, very fast, but I wished that I had known how many end mills y'all sell. Because I needed to get a ball and end mill, and I would have just thrown it on that order with my filament. So let's take a minute and talk about CNC end mills, if you don't mind. I know it's not super high tech, but what is the difference between an end mill that you're going to find in a CNC, manufacturing world and just a router bit that we might buy at the home center?
Yeah, for sure. And that's an interesting question, right? Because if you just look at it from 3 feet, you wouldn't, at an arm's length, you wouldn't actually notice or perceive the difference hardly at all. But it all comes down to an end mill is a product made for milling, right? Material removal of like fine details within a substrate or a block, your raw material. Mm-hmm. And a router is very much made for, I just like some of the desktop CNC machines use flush trim routers as their spindle. Yeah. So you're asking a good question because you're actually you're trying to get the RPMs or out of a spindle. Where like traditional machinery have an entire big gigantic spindle and they can cut steel and titanium and aluminum stuff. Mm-hmm. Some of the desktop ones do use flush trim routers, and there's 2 big differences. One is that the collet size for a router is like pretty standard, right? Like you go to the home center and there's a whole shelf of routers and there's like 1 or 2 diameters of the collet size. An end mill, you can get much closer, right? So you don't need a big fat bit on a tiny little 1/4 inch collet size, right? Uh-huh. So end mills, you can have a 1 inch diameter end mill, right? So that's just a giant thing where you need a special collet. You need the 1 inch collet to fit your spindle there. But that's kind of like the interface side. But I want to address that because the interface is sometimes a flush trim router. Sometimes it's a VFD, a variable control drive spindle that could be air cooled or even water cooled. Mm-hmm. But at the end of the day, sometimes it's a router. But the real meat of like what's the difference is obviously the flutes, right? So the cutting edges. If you're looking for a round over bit, you know that looks like a certain thing, and it cuts with like 2 pretty aggressive wheels that come around. Mm-hmm. But what you're not worrying about typically when you're using it as a router is you're never in a pocket, right? So that you're never like, you can plunge a router down into a piece of wood and you can even like kind of move it around. And that first plunge, you better make sure you get the chips ejected out of there. Otherwise you seize up the whole router. Or if you plunge too quickly, you can imagine. But an end mill is designed with an amazing amount of engineering to make sure that those chips are always flying out because you're always cutting into pockets. And sometimes you're bearing down on like, 3/4 or even half of the diameter of that end mill is like plowing forward. So it's all about chip removal. And you can see that end mills have certain squarenesses of their end mills, and they have certain number of flutes. Flutes are it's kind of the pockets and the cutting edges that have the material eject out of themselves. But material removal is a science and an engineering all in its own.
So there are people out there that's their job. They're 40 hours a week thinking about getting material out of the slot. Okay.
Yeah, hundreds of people's jobs. Mechanical engineers grinding away at differential equations to make sure that the whatever the little chip of, whether it's aluminum or titanium or wood, whether that's making sure that that's not going to bind, or more importantly, like disrupt the edge that you're cutting with.
Okay, so we have a CNC down at the shop, and I have purchased personal bits, nice CNC bits. But if I'm doing something for work, I use one of the work bits, and I'm just using like a regular old 1/4 inch router bit,
Absolutely. Yeah.
And it works, but it is not evacuating the chips. And
Yep.
I find myself having to follow it with a shop vac from time to time, especially that first pass, to get the chips cleared out.
Mm-hmm.
And that's the big difference between them. Gotcha.
Yeah. So, if you're following the shop vac, you're adding an external force to, make sure that those chips are getting removed, not because of the spinning bit themselves, but because your shop vac is influencing the air around it.
Yeah. All right. So, use dedicated end mills for CNC. So you have a pretty, MatterHackers has a pretty wide array of Amana bits, right? Yep. And there's a coating on all of them. Is Astra coating, or what does that do? Is that just more about chip evacuation, friction? What?
That's more about friction and longevity, right? Okay. So you're going to be grinding these things away, and we want to make sure they last a long time. So the coatings on those bits, different coatings for different, premiumness of those materials. It really just means they'll last longer. Okay. From abrasion. I mean, if you run this thing and crack a bit, it happens, your first 3 cuts plan to have redundancies. It's a consumable for a reason. But if you don't crash the bit and the bit doesn't break, it should last a really long time. If you treat it right, clean it, especially if you're cutting wood, you just there's sap in all wood, which destroys your cutting edge. So you gotta maintain them, but the coating on there should help, have it last, give it a really long life. But we hope we can offer all solutions for everybody when it comes to whether it's CNC or 3D printers, just the consumables, the materials, the raw materials, and the hardware. As well as a lot of guidance too, right? So what does maintaining a desktop CNC machine look like? We have articles, we have content that should help guide customers in both the purchasing process and their after purchasing process to make sure that they're succeeding for a long time. Do you have,
and maybe you can send me a link afterwards, do you have anything on feeds and speeds for different materials? Because it seems like that is a feeds and speeds for CNC is like a dark art. It seems like there's not that much information out there without being a material scientist. So yeah, I've just been using the same feeds and speeds the whole time. So that would be good information to grab.
I mean, it is a dark art. And machinists are machinists because they have become experts through practice at that dark art. But at the end of the day, because if you're running a manual mill, for instance, feeds and speeds, my goodness, you better be good at this. Yeah. But because we're using CNC, it's often like baked into the software. And the software, sometimes you can choose, luxury mode or track mode, if you will, on the software to say like, hey, do you want to make sure you don't want to break a bit today, or are you in a little bit of a bind and you got to knock this out? Gotcha. So there's a lot of preset, depending on the software you're using. There's a lot of really great preset settings, especially for woods. Woods are pretty basic at the end. Are you cutting MDF? Are you cutting softwood? Are you cutting hardwood? Yeah. That's pretty much the 3 options you got. And then the flute you use has a lot to do, or the fluting, the end mill that you choose, and the flute choreography that you have has a lot to do with how fast you can go, and then how clean your edge will be.
So what's a good? Let's look at it. Two types of machines that somebody might buy, like a budget beginner, somebody just curious about CNC, or and I know with a lot of budget things, maybe you pay for it in your own time and setup or whatever.
Absolutely.
What's a good budget machine that people might want to look at, and what's a good, like, it's gonna work machine, set it and forget it machine?
Yeah, for sure. So I'll just take CNC specifically, but it has a parallel universe with 3D printers, which we have a lot more experience in.
Hmm.
Yeah, anything that's going to be budget you're going to have to put in the polish. You're going to have to become, I just say you're going to need a little master's degree in using that machine because it's got
Hmm.
little nuances and little, surfaces and, especially on a CNC machine, it's all, if you're familiar with CNC machining or 3D printing, but even if you're familiar with making cabinets and cutting that out of sheet goods, it's like, all
Hmm.
right, where's my datum? Where's my zero? And the budget CNC machines, some of them, you know, there'll be an upgrade option to get you there, but it'll be, you're kind of like, you're guessing where zero is, I
Yeah.
suppose.
Yeah.
Versus a lot of the more premium machines, they'll have like a little touch probe that closes some electrical circuit to make sure that it's really clear where zero is. And from there,
Hmm.
you can start cutting your sheet goods. But we have a lot of, I want people to succeed, whether it's an entry product that they're going to need to put in some time, but maybe it's an experience and they're doing it with their kid who's
Hmm.
learning a little bit about manufacturing, which is a great opportunity. People are going to set up a fleet of these.
Hmm.
So we've got, I'd say, a breadth of options, but some companies to look at, I think, would be Inventables. They've really kind of got the premium market on lockdown. If you start there, you'll succeed.
Okay.
It's all pretty set up. They've got some really premium software that's ready to go. So if your shop looking to get into 3D printing, I think Inventables or Shapeoko. Shapeoko is another one that
Hmm.
we rely on quite a bit around here. Shapeoko's got a breadth, so they're a really great entry point, as well as like some of their more premium products with VFD spindles have a lot of control and stuff like that.
Hmm.
And then the third one that I would just like highly recommend would be the Onefinity line. Man, those things are just built tough.
Hmm.
They're as rigid as could be, and that's going to be something you can rely on for years. Like literally, I think generations. They haven't been around long enough to prove that, but man, when you look at some of the build of that, that'll be there for a long time. We
You
also
would.
have other more like desktop kind of they look more like 3D printers. They're more enclosed, so
Hmm.
that these are great for both schools. If this is like kind of an entry environment, Shapeoko has a really good enclosed CNC machine that's called the Nomad. Much smaller build area. You're talking like envelope sized rather than sheet good sized at this
Yeah. Yeah.
point.
Yeah.
And then in that more smaller space, if you're looking to get into metals or really like some more premium, again, smaller build volume, but Bantam makes a great kind of, enclosed CNC machine. That's great for shops looking to make small parts.
You had used a word that I want to come back to, rigidity.
Mm-hmm.
Is that really one of the main things that separates the quality level of a CNC machine? Because rigidity equals speed and accuracy in machining like that, right?
Rigidity enables speed,
Okay.
but it definitely defines accuracy.
Okay.
Yep.
Okay.
Yeah, not to confuse those two, because anytime you're upping one, you're sacrificing the other,
Okay. Yeah.
potentially, unless
Gotcha.
you're working with something really really huge and built and robust. You can succeed with both. But it's an art. When you're looking to push a CNC machine, it becomes an art for sure.
Yeah.
With wood, again, you can go pretty quick. You could knock out a lot of products. I think it's really, I think it's just amazing how many people can start a business, and that business is like a side hustle that becomes a full time job over the evolution of a few years. We have so many customers that is their story.
Hmm.
They started off 3D printing or CNC machining. Fast forward a few years, and they're a family, and the husband and wife have quit their day jobs, and they're running some sign business or Etsy shop, making whether it's products for you can only imagine the products that we aid in people succeeding at their businesses, from some lady making sewing products to somebody doing local signs, and then the wedding industry is a big industry.
Hmm.
It turns out, just like, coasters and other products made of either plastic or wood that people are succeeding on. So it's some of my favorite stories are those types of customers.
So that segues nicely into something that I see used for decoration a lot, but it feels like the market is moving very, very quickly all of a sudden. Laser cutters, engravers, or whatever you want to call them, laser beams being shot out of whatever's. What's going on with lasers? I see diode lasers. I see CO2 lasers. What's the difference there?
Yeah, it comes down to the power source, right? So a laser is a light. That light can cut through stuff when it's really concentrated. It's think of the old ant in the magnifying glass with the kid on the sunny day. Mm-hmm. So the sun is the most powerful light source that we're aware of, and everyone's trying to get as close to that as possible. So a diode laser is really like your light source is coming from a diode. A light bulb, if you will, LED type light bulb, a really powerful one, really focused. It's got a lot of mirrors to make sure that it gets focused and stuff. But that light source is moderately powerful. So you can get 10 watts. I think you can even get like 15, 20 watt diode lasers, but those are pretty weak at the end of the day. If you wanted to cut cardboard, if you wanted to cut thin sheets of veneer, you'd be fine. You'd be off to the races. The next step would be, an actual tube laser. So that light source is then generated and put through a tube. You still have mirrors to make sure you're getting the gantry systems to make sure you're getting that light in the right spot. But those can go way up in the rating is wattage, right? So you have a 40 watt laser, you have a 60 watt laser. Those are all going to be tube. So when you get even to the bigger ones, they need to be water cooled because generating that light source is a very hot process. So there's a lot of water cooling. But yeah, those are, you're going to look at the wattage rating and the capabilities of each of those machines and what's right for the projects you're doing. There's some really big, really powerful machines that are industrial size, the size of like a desk.
Yeah.
And then there's some that are, the size of maybe like 2 laptops put together. So it really depends on your budget, what you're looking for and what the capabilities are, but the wattage is what will dictate. And at any wattage rating, it almost doesn't matter what the light source is from. Some of the diode ones are a little bit, obviously much easier to use because they don't need the water cooling, stuff like that. Mm-hmm. No matter what you're cutting, it's going to smell like burning. So the fume extraction is definitely an important part of that. So we always recommend if you're buying a laser cutter and getting started, get a fume extractor with that. It's just going to keep the room you're in, or just plumb it outside. You also can do like a dryer duct at home type, just evacuation outside with a little fan.
Because if you're cutting plywood, you're literally burning that plywood with a laser beam, and
you are taking a torch to it. Yeah.
Yeah. Okay. So. Yeah. If somebody was looking to get into marquetry work using a laser, you had said anything, like just about any wattage of laser will cut thin veneer, 40th inch veneer. Is that something that a desktop unit?
Yeah, a desktop unit would work great for that. Yeah.
Really?
And it's often not like, hey, what's the minimum thickness you're going to be doing? Because you should get that machine. But like so many people buy tools that, allow, whether it's a multi little buzzy multi-tool or something like that. It's like, okay, well, all I need to do is trim this one piece of crown molding at my house. But like at the end of the day, at least Americans have the audacity to say, like, well, I should probably buy the biggest one just in case I need to tear my house down with this multi-tool.
Yeah.
And everyone loves to have that kind of backstop of safety. So When it comes to lasers, certainly get the one that's right for you, and there's no need to go over. But often people are like, well, all I need to do is this veneer. But what if I want to cut my laptop in half one day? So people just get, they sort of extrapolate to the ridiculous when it comes to making some of those choices. We see it in 3D printing all the time, though. 3D printing has a build volume. So there's an X, Y, and a Z, a little bit different than the CNCs. You're at that Z height, so you can make parts really tall. And everyone wants the biggest machine. Most people are not making anything bigger than the size of their fist. But what if you want to make a helmet for your kid at Halloween? You want to be able to print some human head sized things. And that's just, I think it's great. It expands the market, but it's not always what you need. So when you come to like entry budget and minimum viable product of what you're looking for, just make sure it fits your budget, budget and size dictate a lot of those things. And then ease of use, which we already talked about, how much of a master's degree you're going to need to succeed with it.
So in desktop lasers, for somebody, let's say somebody wants to be able to sign their work, maybe put a logo on some cutting boards they're making, and cut out some veneer for marquetry purposes. What are some recommendations that you would have, product-wise?
Yeah, again, kind of the same answer as with the CNC machines. Like MatterHackers.com is a great place to shop. It's a great place to learn, and it's a great place to make an order. But honestly, like, we're a company that just loves the guidance process and the enabling. We're aware that even listeners to this podcast, fine people who identify as fine woodworkers, like we're not, digital fabrication, laser cutters, CNC machines, 3D printers. We're a far way away from like any really good market penetration, which means we've got a lot of work to have these types of conversations. And I'd love to switch this and ask you next.
Yeah.
Like, hey, what are you doing with 3D printers that these people could learn from, be enabled, like be inspired by? Because it's a big barrier to say, like, I'm going to, some people hear that a CNC machine or a 3D printer is like, oh, it's cool. It's like a microwave. You just push button. What? No, let's pump the brakes on those expectations. Yeah. You're going to need to do some learning. You're going to need to fail a few times. I'm an engineer, so failing is part of succeeding. It is the story within succeeding. But honestly, MatterHackers.com, if you're looking to learn, looking to see what budgets might be enabled, because compared to fine woodworking tools, these are pretty inexpensive products at the end of the day. Yeah. Very approachable. They're easy to learn. Sometimes people are, I would say, like, they're in their own like drumbeat of how to make something. And if you're someone doing, inlays, and so, you got your way. But let me tell you, you can buy your time back if you're using some of these tools the right way. You get what you get from the learning is each individual, again, let's go really complicated inlays. Yeah, man, you said that. I've never done an inlay in my life. I would call myself a moderate woodworker, not a fine woodworker. But man, one Christmas, I just made cutting boards for my entire family. Had like the state of California cut out on them, had the MatterHackers logo cut out on them. I published it into an article, but know that article was not written by someone who's done a lot of inlay work in their life. It's just from a guy who's, pretty well versed in digital fabrication and figured out how to turn on a CNC machine and throw some walnut and some materials in there. Software guided me most of the way. Mm-hmm.
Well, I mean, yeah. So it's naturally going there. So 3D printing. The listeners of this podcast have heard me espouse.
You've heard done it before.
Well, I do consider my 3D printer to be one of the most important tools for woodworking in my shop.
That's awesome.
And I think that I love CNCs. I love having access to a CNC. I love tinkering with that stuff. Eventually I do want to get a laser cutter, blah, blah, blah. The 3D printer, and this is with a little d, it democratizes fabrication to me, where
Absolutely.
I can make a 3D printer do anything I would do with a CNC. It might take longer. I can do router templates for inlay. I can do all sorts of things right now. I build ukuleles, and I just finished this morning, pulled it off the plate, a radius dish that
cool.
that allows me to sand in a 15-inch radius into the back of a thing. It is one of those things that I use it nonstop for woodworking. And I am constantly trying to get woodworkers to realize that you can get a 3D printer and you don't have to become a 3D printing hobbyist.
Yes. And if you look on YouTube and you search 3D printing, there's a lot of great content. You can learn a lot. But so much of the 3D printing content is people talking about how they're using 3D printing for 3D printing. Again, I'm a mechanical engineer. I only 3D print things that are functional. Yeah. My house is full of like little adapters, little rod hanger extensions, things like that have allowed me to use my skills to use the 3D printer as a tool. And I genuinely think, much like yourselves, I've got a table saw at home, got a band saw, got some, sanders that are well used. Mm-hmm. Many people don't know that their next purchase should be a 3D printer because it enables the success of so many of the tools that you've already have.
Yeah. I use it, if I need to, if I find myself having to draw a 22.5-inch angle a lot, or not, I'm sorry, a 22.5 degree angle, not half inch. Mm-hmm. I print out a little thing that sits in my drawer, a little gauge block that's 22.5 degrees, and boom, I pull that out and there it is. I make setup blocks specifically for the tasks that I do often.
Yeah.
And it saves me time and it saves me money. I found myself needing to route, I needed a router collet bearing that was, 2 inches wide in order to offset a routing task. And they don't sell anything like that. And this was this was one of those aha moments that I had where I sat there and said, I wish I had a router bit that did this, or a router collet that did this. I'm using the wrong word, not a collet, a guide. And, all of a sudden I said, wait a minute, I can just make that. I can make that thing. I pull up CAD. I have spent the time and the effort to get decent with a CAD program. Yeah. I pull up CAD.
That's not your background, right? You're not some CAD extraordinary or like School of Hard Knocks.
I went to music school. No, I'm a musician, recording engineer turned woodworking enthusiast. I pull up CAD, make the thing, and then I send it over to my robot, and that robot does it while I'm sweeping the shop or something. I'm doing two different things. I put it on there.
Even if it's a 4-hour print, that 4 hours is a passive time.
Yes, that is key. But there was a moment I was very proud of myself, and I posted it on Instagram, and I had a whole lot of people say, oh, well, I could do that with this $3,000 tool, or I could do that with this $2,000 tool. I said, mine cost $250.
Yeah.
And I'm talking to a 3D printer dude. So, it was an Ender 3 Pro, which is going for what? Yeah. 200 now?
Yeah, I mean, you can get those for a screaming deal. Yeah.
and a 3D printer allows you to make the very specific thing that you need to make quickly, passively, like you said. Mm-hmm. And if you use it once and you throw it away, no big deal. If you need to use it more than one time, put it in a drawer.
It's an addictive drug. If you use it once and you succeed, you go back to that tool. I mean, that's my experience anyhow, is you often go back to that tool. And and I'll just double down on your example of that didn't exist in the market. The gauge block that you needed didn't exist in the market. Well, I've been in a pinch where I was like, well, this project has to go out the door tomorrow. And I see it's not something available at the home center, but it's something available online. It'll be to me in 6 days. All right. Well, let me draft it up real quick. I'll print it out. Maybe it'll work. Maybe it won't work. But 2 hours later, I've got it in my hand. Yeah. And that was my specific example was a router template for a certain shape that it needed to fit into a socket of. And it was available, couple $100 shipped to me. You could do expedited shipping, but it wouldn't have gotten to me in time. No. So I was able to solve my own problem there. Yeah. And then again, once you succeed at that, you realize that, okay, it save you time. It's actually cheaper. 3D printing materials after the investment of the tool, quite inexpensive. Mm-hmm. We can get into breadth of materials later when it comes to 3D printing. The basic materials are really inexpensive. But once you succeed with it, and this goes back to the YouTube content of 3D printing for 3D printing's sake, you find yourself getting there because all of a sudden you realize that your ductwork for your dust extraction needs some magnets, and you need to be able to switch it from this machine. So you're designing your own ductwork and quick magnet releasey things and different ducts for different machines, but you can succeed at all those adapters, and you got a machine that passively does it. You just punch in some diameters to your CAD, then you're off to the races.
Well, that dust collection fittings is one thing that I think is worth the price alone of a 3D printer. If you're setting up a shop, I have, you could see it right behind me. I have that one.
I see it. I see those
Bosch
tubes.
hose, and that I don't have a big dust collector in my shop, but that Bosch hose gets hooked up to every machine, and none of those machines are designed to fit. That hose is designed to fit on the end of a tool, like a Festool style. I think it's a 22 millimeter fitting.
Yeah.
None of my machines, my 1950s Delta sander doesn't, as well as my rigid oscillating spindle sander doesn't. So everything has a dust collection fitting that I have printed up.
And you put the fitting on the tool. You made an adapter from the tools collection to a universal your collector, correct?
Yes. Yes.
And did you throw magnets in it?
No, that'll come. So
yeah.
we bought it for our CNC at the workshop. On Etsy, I bought a dust collection shoe for the CNC, and it has the whole magnetic brushes thing that pops on there. And it was like, oh, okay, this is too slick. This is great,
Yeah.
But yeah, I've seen
magnets are the answer. And if you're making your own, eventually you end at neodymium magnets, and then you just like throw that thing kind of close to that, and it goes and just clamps right in like it's something from a Star Trek show.
Now, I do have magnets on a dust collection fitting for my bandsaw, and
awesome.
That basically it's a a dust shroud that is, I downloaded it from Thingiverse or something like that. I didn't model this thing. I didn't do anything other than download the file and put it on my printer and go.
Yep.
And yeah, there's 3 or 4 magnets that keeps it stuck to the bottom of the bandsaw table.
Yep.
And it just basically puts that vacuum right at the source of the dust creation. And that's a print that I recommend everybody go and do for a bandsaw. It's incredible. Yeah.
And you bring up a good subtle point of, I think like, okay, I want a 3D printer. You guys, these two guys convinced me I need a 3D printer.
Yeah.
But what parts am I using? And I think we breezed over it of like, you need to design something in a 3-dimensional space on a computer, right? And that's not trivial. I have a degree in engineering where I took 2 years of how to, design in SolidWorks. SolidWorks is the program I use. It's super expensive. It's made for engineers. There are free programs out there though, that are meant for that are professional programs that are paid for, but like if you're just the one dude in a shop, you can use it for free. They definitely like, there are Autodesk solutions for free tools. And there are really rudimentary programs. I have a 6-year-old. I'm starting to teach her how to use Tinkercad, which is more like the Lego version of using some 3D design space, getting to know it. So the breadth of to be able to learn, there's no escape in putting in some time and understanding how these Lego go together and how to escalate to a little bit more free form designing. But let's say you're intimidated by that and you want to shine it all. It's okay. There's a great community of you making things for your shop and me making things for my shop. And when I'm done with them, I post them to repositories. So Thingiverse is the most popular repository out there that you can go download things that people have made. So you can probably, at this point, you can search your model of car to see if there's a shifter made for it. You can search your model of bandsaw to see if there's an adapter, even from your bandsaw to your dust collection system. There is probably an adapter that exists. And even if it's not the perfect thing, modifying something becomes really trivial, right? And then you can print it out. So these designs, they're posted. They're all free. You can go download them today and not 3D print them just to see if they look like something that would fit. So dipping your toe into the water, there's a fork in the road. Am I going to design my own things, or can I download something from this open source community of people, engineers, hobbyists sharing some of the designs they've made themselves that are really well polished? I went to go sit down at my computer, and I'm really confident I could sit down. I could make you anything. I've got $10,000 in SolidWorks. And I was like, all right, I'm going to get an adapter to hang my car charger on the side of my wall because I'm sick of like looping it around and all this stuff. But then I decided, like, screw it. Is there an easy way? Oh, yep. Download, print.
I do it all the time. And, one of the very first things that I printed when I got my 3D printer was, I'm bought into the Milwaukee 12-volt drill format. Dude. And I was like, it'd be great if there was like a thing I could screw onto the wall and put my batteries in
hang them all up, line them up, knock them down.
And that was the very first thing I printed, I think. And, and the first thing I do when I go to make something is I look, it has some, is this a novel idea, or is this an idea that many people have had before me and someone was kind enough to put it online?
There are no new original ideas these days. There's just modifications of other already thought of patented ideas. But I think you're going down the right track, right? But maybe you've got 3 batteries and the one online has 2, but there's a way to customize it. And it's really trivial to take the 2 and add a third bank to it. That's like really easy to do, to kind of copy paste one and put it to the other digitally to succeed at the actual part that you need. And I think that, that is like a big overlapping, if I were to make a pitch to your audience to say, hey, why do I need a 3D printer? Well, if you're into woodworking in the way that a lot of, the listeners are, you understand that customization is a big part of it. And no, cabinet that you've ever made, no guitar neck that you've ever assembled, no ukulele that is like, not one is the same as the other, because that's what we're into. 3D printing is the same thing. No print needs to be the same as the last, whether it's printed in a different color or a different material, or you throw, you got 2 daughters, throw one daughter's name on one light switch cover and throw another daughter's name on another light switch cover. And then you can put a giraffe on one and a unicorn on the other, but you can really get elaborate. Like, oh, I need a light switch cover. Why not put a name on it? Yeah.
Yeah.
Customization.
And I, quite honestly, I think, one draw for me was, I wanted my son to grow up in an environment where if he thought about something, we could make the thing, right? And sometimes the answer to make that thing is take a piece of wood and get rid of the bits of wood that aren't that thing, right? But sometimes, and this weekend we had a very geeky weekend. My son and I, he he sat down.
Tell me all the gory details.
Well, we started by dismantling a sewing machine just for fun. But he also he went on Tinkercad and made a little thing with a name on it, and it's just a little block, and then he sent it over to the printer, and it printed while we were in Fusion 360 doing a totally different geeky cat thing. But
how old is your son?
He's 10.
10. Yeah, dude, that's a great, I think like 9, 10. That's the place to start. And they are geeky stories that turn into formidable memories. And then, at least from my background, I was tricked into being a mechanical engineer. My grandfather was a mechanical engineer who owned a machine shop that made aerospace parts. Okay. I saw metal chips flying around, and I was like, I want to be a mechanical engineer. Turns out I just wanted to be a machinist. So he tricked me into all the suffering steps of college. Yep. But it did. It made me, those were formidable memories that made me turn into a mechanical engineer. And I thought, I currently have the hubris thinking like, yeah, I could make anything. I got it.
I think I have that hubris. It might take me a long time, but I'll figure it out.
Yeah, suffering's part of the journey, you know. Failing is part of the journey, to be honest.
Yeah. So let's talk about different materials that. So all right. So somebody wants to get into 3D printing. They've got the printer, right? So there's two types of printers that people talk about. There's filament printers and resin printers. Let's say this person is not wanting to be a 3D printing hobbyist. They're wanting to use it as a tool in their shop. Yep. Which would you recommend, filament or resin?
Filament for sure. It's a way, unless you need the detail. The reason you would go resin is because you need high detail. Unless you need that detail, and let me just go with the like normal folks around the office detail who prefer resin printing, are like making video game minis or board game players, things like that's the level of detail you would need to achieve to get that, like tiny parts of that level of detail. Otherwise, for the 99% of this audience, I assume, you're looking for functional parts. You're going to go with what we'd call an FFF machine. So a fused filament fabrication is the reason that it's FFF or FDM. And that takes a spool of plastic in a small diameter, a long wire that's put into a coil, and it melts it. It's a glorified hot glue gun controlled by a computer. That's what a 3D printer is. I described
it as a hot glue gun the other day too. All right, gotcha. Good. I'm glad I'm not the only one who does that. So
glorified hot glue gun controlled by a computer, and then the design that you end up with, or the design that you input that you ask the machine to make, is prearranged in a digital fashion on your computer.
Now, these machines are being made by the hundreds of thousands these days, right? So that helps the price.
I would say tens of thousands.
Tens of thousands?
I mean, there are hundreds of thousands of printers available in the market, but not made by like one.
I mean, I just extrapolated. I have 3 in this room, so I figured there's... But, so...
I've got 80 in the room next door, so...
we're the wrong people to be extrapolating this number then. So, like, we're talking about $200 for a printer or so can be had. At
the very end, you're talking about the minimum viable price you could spend to succeed at 3D printing is about that point. I'm terrified by a printer that's $200 because of the time. I value my time. My time is worth more than learning how to 3D print with a printer. But that said, I've got a 12-year-old nephew who's, definitely coming upon one about that price range come Christmas. But me, myself, I value my time. Again, and I'm a person who, and many woodworkers do charge for their time. What's your day rate kind of for this? And if you're buying a $200 printer, schedule in 3 or 4 days for your day rate. And that's whatever your day rate is. Okay. Pencil in that on top of it. And that's where I would come to say, like, all right, if you're really looking to get into it, you're going to spend, you can definitely spend $200 and get a printer. You'll put some time into it. spend $1,000, $1,500. Now you're looking at a tool that is like real plug and play. You'll get going right off the bat without worrying about build surfaces and temperatures and clogging nozzles and extruder gears messing around and stuff like that. So there's an entry point. There's like a highly recommended, and then there's like the professional tool, like anything.
Yeah.
You could put a frame together with a cordless Ryobi if you wanted, but I wouldn't rely on it for a long period of time.
And for me, I bought the $250. I think it was maybe it was $300, but bought it not knowing if I would use it. A great
reason for that tool to exist. The Harbor Freight.
Totally, and it's a valid thing. Yeah. It's like, are you?
I need a hammer drill
once, or are you gonna? And I found myself using it all the time. Upgraded to just about a month ago. Upgraded to a bamboo, and it's a set it and forget it
to be making. Yeah,
that thing is amazing and
ridiculously. And like you talk about passive time, you spent $200 to start. Great, fine. You need it once. You went to Harbor Freight. You got the one tool, and when it atrophies, you won't be sad. And then your Bamboo Lab, somewhere around like $1,500 was your next step. And I think that's a really great. That's like you're walking up the ladder exactly as I would recommend, frankly.
Yeah, and it's the type of machine that I can sit there on the couch and pull up my phone and literally look at the print as it's happening. Built-in camera and all of that stuff. So I really recommend that line of machines. Are there other machines out there that you recommend that are also just kind of, I don't want to make this my part of my personality. I just want a thing that works.
Yeah, and I'll just answer for a third time to say, check out MatterHackers.com. Is it like, what's your budget? What are you looking for? What are you looking to do? We try to describe those products in a really high level of detail. But yeah, something like a Creality, great place to get started. Something like a Bamboo, it's something good to graduate in. Or if you want to skip the master's degree of kind of learning a lot of the nitty gritty about what each independent subassembly part of a 3D printer does and means, then that's a great place to start. Those are we sell a lot of those Bamboo Lab printers. We have some really great bundles configured so that you've got kind of the materials, the surfaces that you need, so you don't need to think about anything. Like the basic one's fine. We choreograph some bundles for you to succeed. But then as you walk up the ladder, and if you're someone who's an engineer at Tesla, you're not going to want to mess around with any of that stuff. You're probably going to go right into like an Ultimaker, something that's like really got a lot of, user experience built into it that's going to just work off the shelf. And if you're looking to print some big things, maybe you'd look into like a Raise 3D or a BCN. Those are, they're wrapping off a lot of companies that you can learn more about and really compare on MatterHackers.com. But at the end of the day, what's your budget? What are you looking to do?
Yeah.
And how much are you looking to learn to get there?
So let's talk about the material though, because we've just mentioned it as filament. Sure. I would assume 90% of what you sell is PLA. Am I wrong?
Far less than 90%, but certainly like 50% of what we sell would be PLA. So again, we got off track. There's the materials are the kind of the monofilament that melt. They are the glue that goes into the hot glue gun called a 3D printer, and a lot of materials that you would recognize the name of. ABS. If you ever done irrigation, you've cut. The smell of cutting ABS. Nylon, another one. Your car bumper is probably made of nylon or polypropylene. And these are all materials available to be melted and put into form to create your part. And, any engineering process goes through the all right, what do I need? How am I going to make it? And what material am I going to make it in? So what do you need? The most basic, you already brought it up, the most basic material, probably the spool that comes with your 3D printer, you'll get some, would be PLA, polylactic acid. It's not an oil-based product. It's actually made from, I'll just go straight to the punch. So globally, they don't like using the word corn, but it's made from corn. The lactic acid that's distilled is made from corn. But if you were in a different part of the world with a different uh, uh, product that you could distill down into lactic acid like rice in an overseas area. So you can use locally sourced. It's not a polymer based on old dinosaurs, which is kind of cool. That's the most basic material. And the reason it fits for 3D printing really well is that the prints that come off the build plate are quite tough. It's stiff. It's a good material. It's going to last you a long time. There are prints that I carry around every day that are made of PLA. Good material, really robust. It's got a really low melting point. And if you're using the 3D printer and you understand that, okay, the lower the melting point I have, the less differential from the environment, the air that I'm in, the better off you are. And the lower you'll actually warp, and warping is a big failure mode that can happen with 3D printing. Warping is the reason that you hear a lot about print temperatures. You hear a lot about build surfaces. All of these are inputs to try to reduce warping, because the moment your flat piece of 3D print starts warping on the edges, the whole thing goes kaput. You know, that's that's you having a kickback on a
only you don't know it immediately.
Yeah. So PLA is going to be your most common material. But if you need something outside of PLA does have corners of use cases that it's really poor for. If you're going to have it in a really hot environment, it's got a low melting temperature. So it's just going to deform if it's in a high temperature environment. But if you got a high temperature environment, ABS, PETG, nylon, those are all great solutions that you should look into. And again, we've got all of the materials you'd ever need. We've got about 4,000 different material options at MatterHackers. So if you go to MatterHackers.com, poke around with the filament, you can see what's available. And it's all really available. Materials that you've heard of: ABS, nylon, PETG. PETG is like a water bottle material, so you can print from that. So there's a specific page on MatterHackers.com where we try to associate a material name that might be familiar to you with a product that you would identify it with. ABS, irrigation systems. PETG, water bottles. Nylon. Your cordless drill is definitely made out of nylon.
Really?
Probably made out of nylon. Probably made out of glass-filled nylon, which is also an option. We can stiffen materials or change the impact properties or change the robustness of a material by adding fillers to it. So glass-filled, the normal thing. Like literally, if you got a cordless drill, it's got glass-filled nylon is probably most likely the material it's made of. You get carbon fiber filled nylon, which like really adds to the stiffness. That's like, we're talking metal replacement material at that point, really, which is cool.
So a question for you for personal reasons, on the other end of the spectrum, I'm thinking clamping calls where some give would be nice. I've started printing TPU, which I don't know what that means, but it's flexible. Tell me about printing TPU.
Yeah, so TPU is just the U is for urethane. TP is the thermoplastic. So it's a thermoplastic, a melty
plastic, urethane.
Urethane, a rubbery type of material. Again, like breaking down the materials that sound complicated. Polypropylene sounds like a complicated thing, but it's the most commonly used plastic known to man. So you've definitely held polypropylene today. Did you make your 10-year-old a lunch and you put the little flappy parts of the plastic lid? Those are polypropylene. You can make living hinges out of polypropylene. You can 3D print with polypropylene. Therefore, you can 3D print living hinges if you choose the right material. And those flappy hinges on your food storage type things, that's a material that's available. The urethane is going to be so it's TPU or TPE, so the urethane or an elastomer. Those are all rubber typed materials, and they're thermoplastics. Many rubbers are vulcanized or heated up. They're thermoset rather than a thermoplastic. So our type of 3D printing really needs to focus on something that can be melted in the hot glue gun controlled by a computer. That said, think gaskets, think like gaskets for your car, gaskets for, like a little hose bib gasket. You could print that all day long. It's very available. When you print with it, the sacrifice you will have when it comes to succeeding with flexibles, like the category of that would be called flexibles. It's like you're going to sacrifice speed. You can't print very fast, mostly because there's an extruder motor, like two gears that are meshing together to push that plastic into the hot glue gun side of things, the part that's heating up. And you can only push that so fast before the whole plastic, can't push a hose back onto the reel. You got to pull it, So if you're going to push it back onto the reel, you got to go pretty slow and pretty gently to push a hose back on the reel. But the hose also needs a certain amount of stiffness. So some, flexibles are measured in durometer. Durometer is the unit of measurement, familiar term. Its rating system is all over the place. But you can only reach 3D print certain durometers. So you can't get super floppy flexible. But you can get to like tennis ball, sole of the shoe type flexibles for sure.
I'm one of the things I want to do this week is I've got a couple dozen clamps with the missing little rubber clamping pad. And I thought, wait a minute, I've got a roll of TPU. It doesn't matter if they're purple on my orange clamps. That's fine. And I was going to, just model up and make clamping pads, to go on there just to keep from marring up my, my fine wood surfaces.
Perfect.
So, yeah.
And so durometer is the unit of measure to say like, hey, how stiff is this? How much does it deflect? How rubbery is it? And that's only one of the inputs to designing a successful part the way that you need it. Like the design of the part can make it more or less flexible, right? Yeah. If you make it thicker, it will become less flexible. If you make it thinner, it will become more flexible. So you've got, if you don't have the right durometer material, that might be your first instinct is I need a more flexible material. Now you can modify the design. You can put can you bend plywood? No, you can't bend plywood until you kerf it. Then you can bend it all day long. I've seen some really rad light fixtures of bent floppy, so it's the same kind of thing. Cardboard or, stiff wood is stiff until you let one of the veneers, let it do its thing. And then it's pretty flexible. So think of that same mindset when you're doing material choices of not to be limited by the substrate itself. But you can design your way into succeeding with a lot of the materials.
So, I mean, I think the point for me is there's a whole different set of tools out there. When we talk about CNC machines, that's a very familiar set of tools. Laser cutters, everyone kind of knows what we're doing with laser cutters. But add 3D printers into that mix or a water jet, and all of a sudden there's a whole array of digital fabrication tools that I think woodworkers need to be considering in their workflow.
Sure. And I think the reason that, again, I said it pretty clearly a couple minutes ago that MatterHackers, there's not a lot of knowledge base around 3D printing, digital fabrication in general. And you brought up laser cutters. People know a guy with a laser cutter and they know what. Because they're making final products probably with laser cutters. The kids box, science boxes, the KiwiCo boxes. And so it's like, that's really just a bunch of laser cut stuff, right? So you run across commonly laser cut goods. But one of the best tools, hey, do you love table saws? Some people love table saws, but most people love what table saws make.
Yeah.
Right. So, do you like your closet? Because your closet was made with a bunch of table saws and labor that was put into it. But when you see your beautiful closet, you don't think, wow, I really love table saws. So 3D printing stuff, because often the way that you've described you've succeeded and the way that I most commonly use them is not 3D printing to make 3D printing good, but 3D printing to make tools that you already have way more powerful. I love a router. I love a good router. But you know what I love more? Being able to get a template made that is passive time to be put in to be able to succeed with that router.
Yeah.
So often I think 3D printers are misunderstood because you think of their final product as like, cheap plastic, not as good as injection molded. I often joke, this is like an 8-year-old version of my joke, where I brought home my first 3D print to my wife, and she's like, looks kind of gross. What are those lines? Because your expectation of something plastic is smooth injection molded. Yeah. But if you're using it as a tool in your house, also I think layer lines and 3D printed parts can be really elegant when you instead of trying to suppress them, you bring them to the surface. There's some really great designers out there that are using the layer lines of 3D printing to say like, yeah, this was 3D printed. Check it out, bro. So all that to say, like, yeah, there's a lot of work to be done to say like, hey, 3D printers, laser cutters, CNC machines are all a tool that you can use and you should adopt because it's going to save you time. It's going to make things cheaper. You're going to be able to do things more precisely. You're going to be able to do things. You're going to save on like all aspects of a tree of value. 3D printers help and they come in. A little bit of a learning curve to get up there. You gotta step up to that plate. I often talk about probably 4 or 5 years ago, we'd go to trade shows and there'd be a metal CNC machinist. And he'd be like, oh, what are these things? Get this out of my life. Right. And they'd be like, oh, this is going to take my job one day. Right. That was one aspect of a CNC machinist that it was. The other aspect was like the CNC machinist going, hey, what's that? You think can I print the jig to flip the thing over rather than spend more time on CNC? I was like, yes, you got this, right? Yeah. And I genuinely think, one of those people are in business and one of those people might not be in business anymore because if you're not adapting, you're not, keeping up with market rates on people that are being really efficient with their time and their materials. 3D printing is the way to get there. I genuinely feel that.
I agree. And I think that it's made my shop time. I hear from a lot of people say, I sit in front of a computer all day. I don't want to sit in front of a computer. I think when I'm sitting in front of a CAD program, I'm being creative. I am being it's the same brain synapses firing as when I'm shaving 2/1000ths of an inch off of a piece of wood with a spoke shave. But that's not going to be for everyone, and that's fine. But
it's the same mental wheel when I'll just call it digitally iterating, right? You're designing, you're fine tuning your design to get there. But also like, don't discount the fact that you're like, if you need something and it needs to be really precise, plan to print it twice. If you've got a really detailed design product, like, I could cut one piece of walnut or two. It's a small thing. Might as well just cut two, just in case, backup plan. Yep. So iterating is the positive way to talk about failing once, but succeeding by the second try. It's the same mental sort of acuity that you're going through. Yeah, for sure.
Cool. Well, I know for me, I'm not getting a dime from this. I buy my filament at MatterHackers. Just the other day, I was looking into Nylon X and I Googled it or whatever, and I went to MatterHackers and y'all taught me everything I think I need to know about nylon or whatever the new thing was that I'm trying to learn. So it's a great place to learn, to educate. You have a YouTube channel, you have a podcast, right?
Yep.
And the podcast is mostly 3D printing related, or?
Yeah, it's kind of a deep dive into, we kind of switch episodes. One will be like a really great use case, someone who's using 3D printing to succeed. Whether it's, medical devices or woodworking or automotive applications, whatever it might be, customer stories. And then many are deep dives on materials, right? So cool. Someone who's like, oh, I've heard of nylon. How would I use it? What are the, we even at the end, if you last the whole episode, we go into settings and tips and tricks at the end.
Oh, cool. So cool. Right on. Well, thank you so much, Dave, for coming on and telling us all about what y'all do at MatterHackers. And it's who knows what you'll be doing 5 years from now, because there's going to be some new technology. I'm sure you'll be right on top of it though.
Yeah. Thanks for your time, Ben. I really appreciate it. I hope you found value in this conversation. I know I valued this conversation quite a bit, and yeah, just hopefully your users think of MatterHackers when they're looking into anything digital fabrication. And if you're looking to research CNC machines or 3D printers, how to get started, what materials to choose, what might be good for you, what fits within your budget, MatterHackers.com is a great resource, and we built that with intent, and we are very customer focused. And we didn't even get to the part where we got 2 warehouses around the country. So we try to sort of compete with getting you something in 2 days, because we know that's sort of the e-commerce expectations these days. But we're very customer focused. So
I ordered this on a Thursday afternoon. I had it Saturday by 1. So there you go.
There you go.
I appreciate that
in real life.
Yeah. Awesome. Well, thanks.
Thanks for your time, Ben.